Let's suppose that AS200 originates a prefix, and that the paths that result from the original BGP routing are shown in green. Let's now suppose that AS100 seeks to become a man in the middle. If the original prefix being advertised was P, AS100 could also advertise the prefix P, but we want to make sure that AS100 maintains a path back to AS200. Now that path already exists, it's right here, so what we want to do is make sure that neither AS10 nor AS20 accept this hijacked route. The way that we can do that is through a technique called AS path poisoning. So if AS100 advertises a route that includes AS10 and AS20 in the AS path, both of these ASs will drop the announcement because they will think they've already heard the announcement and don't want to form a loop. On the other hand, the other ASs on the internet, in other words, every other AS that's not on the path back from 100 to 200, will switch. And now all of the traffic from other ASs en route to AS200 will traverse the attacker AS100. Now, a trace route might look awfully funny taking this circuitous route, but actually the attacker can hide its presence even if the sender is running a trace route. Recall that a trace route simply consists of ICMP time exceeded messages that result when a particular packet reaches a TTL of 0. Now typically each router along a path will decrement the TTL at each hop, but if the routers in the attacker's network never decrement the TTL, then no time exceeded messages would be generated by routers in AS100. Therefore, the trace route would never show AS100 on the path at all. So now that we've talked about the importance of origin authentication and attacks against it, let's talk a little bit about session authentication.